Nabb here. Today we're going to cover suspension geometry. So why does suspension geometry matter? Well, suspension has really two major functions. One is to dictate the wheel position. The other one is to control how the wheel forces are transmitted to the body of the car. So wheel position, that would be your camber, or the angle on the top of the wheel in and out. Your toe, which is the direction that the wheel is pointing. The geometry will also dictate the caster angle, which will change the camber with steering. It also will dictate the tread width change, which is how much the wheels move in and out as this geometry moves up and down on the suspension. Wheel forces. So another important function of your suspension geometry is to transfer the wheel forces from the wheel to the body of the car. Your geometry and suspension will dictate the motion ratio for your springs and shocks and your anti-roll bar point. Moving your spring and shock further outboard will increase the effect the rate has at the wheel. Same thing anti-roll bar point. Another important force transmitted through the suspension is your jacking forces. Jacking forces are the vertical component of your lateral force at the wheel. So if the wheel pushes out here on the hub laterally, in the strut suspension, that lateral force goes into the body of the car via the upper strut mount and the lower control arm. Changing the position and angle of these two mounts will change the amount of force that pushes up and down in the body. For example, if I pick up the lower control arm points, more force will be transmitted vertically, pushing the body up in this corner. If I lower it down and to get it below level, it will actually push the body down in that corner, which would decrease the wheel load in that corner. Another important force transferred through the suspension is your anti-squat or anti-dive. Now, from the side view of the car, if I were to raise the back point during braking events, it acts just like changing the control arm does laterally. The forces now act along this control arm, and it can resist or increase the amount of dive or squat you have, depending on whether you're braking or accelerating. The steering torque, or the effect that the wheel forces have on your steering loads through your tie rods and at your wheel, are dictated by the geometry as well. You see this as trail or scrub, and moving the steering axis, the point at which your geometry rotates about, inboard or outboard, or forward or back, can increase or decrease the amount of effort at the wheel during cornering events or braking events. This will also change the amount of effort you feel during braking events or acceleration events on a front-wheel drive or all-wheel drive car, because the forces during acceleration pulling the wheel forward will be transmitted through the steering linkage depending upon where this steering axis intersects the ground. So you decide to lower your car. What does that do to your geometry? Well, most cars that we race with have fairly flat lower control arm angles for strut cars, and when you lower the car, you'll have a net down on the inward points on your lower control arm. That will actually create more negative jacking, which will push the car down in that corner and reduce weight transfer on that end of the car. That's also sort of like reducing the anti-roll bar rate on that end of the car, and so you need to weigh in the consideration what that does to your roll balance. You also move into a different position on your camber curve. And camber curve is how much your camber changes as the geometry moves up and down. For most cars, this will create a camber curve that's negative or inverted, where you'll lose more camber with travel. This will probably require additional static camber to get your camber mid-corner back to your original target. This can also create some jacking force changes in your anti-squat or anti-dive if the 2 points are not level and equal in height to begin with. So how do we fix the car after we've lowered the ride heights and changed our geometry? Well, one of the solutions would be to simply change the inner pickup points for the lower control arm. we could cut, weld, move, or relocate those mounts and simply pick the control arm back up so that it was back to the original angle that the car had from the factory. Another way to fix your geometry on your lowered vehicle is to change out your ball joints. These are tie rods, but tie rods and ball joints can be ordered in different heights. This can act the same as lowering or raising the outer pickup point, which can get your control arm angle back to 0. Another option would be to use a tapered reamer if you need to shorten your ball joint and just drill your knuckle to allow the ball joint to sit deeper in the knuckle. Another option, if ball joints are not available for your vehicle, would be to use a ball joint extender. This can lengthen the ball joint, which for most of our vehicles would get the control arm angle closer to factory. You have to be careful with extended ball joints though, because many of these are made very poorly and there is a lot of stress that goes through these joints. You'll have to make sure you use proper fasteners. Many of them should be welded onto the knuckle, and in general this is best left to a professional shop or to a professional race team. Some vintage vehicles have problems with inverted camber curves. You find this in 60s, 70s, and some 80s vehicles, and on those vehicles the geometry was designed around the tires at the time. On those cars, the vehicle will actually lose camber as it goes into compression travel. For almost all modern tires, you're going to want to increase your camber with compression travel. And the issue is, how do you fix that? Well, one of the ways you can fix that would be to change your knuckle out. So for a struck car, you would change the distance from the center line of your hub to your ball joint. By extending that, you can get a control arm angle that would be inner points up, which will give you more camber as the suspension travels. For suspensions that do not use a strut, that have 2 control arms, you can extend either the upper, the lower, or both ball joints to make them act taller. Done correctly, this can also give you a camber curve that adds camber with compression travel. You can also use ball joint extenders as an alternative to making the steering knuckle taller. Or you can use taller ball joints as another option. Many of the cars we race have next to no jacking force. The trend in newer cars and newer race cars has been towards higher jacking forces. So how do we change that in our cars? Well, if you want to increase the jacking force in your car, one of the options would be to raise the inner pivots of your lower control arm, lower the inner pivots of your upper control arm, run a taller lower ball joint, which acts the same as angling the inner pivots up and the outer pivots down, running a taller spindle, meaning more height between the center of the hub and the lower ball joint, or using ball joint extenders like we spoke about earlier. Adding more jacking force to your car can act like adding more roll bar stiffness on that end of the car without having to purchase any roll bar and without having to connect the 2 wheels, which transmits bumps from one wheel to the other across an axle when you hit single wheel bump events. Bump steer. What's bump steer? Bump steer is toe changes that happen as the suspension moves up and down. Bump steer is caused by differences between the tie rod linkage movement and the suspension hub and knuckle movement. On struck cars, this is usually caused by a difference between the angle of the tie rod and lower control arm. It gets more complicated with suspensions that have 2 control arms, but on those, same rule applies, that the tie rod is not moving in the same arc as the rest of the suspension. You can fix bump steer in a couple different ways. One of them is to get tie rods that are longer or shorter. You can also use your tapered reamer of the correct angle for your particular tie rod and ream the ball joint deeper. If you significantly change the geometry and you need to substantially shorten the ball joint, on some vehicles it actually is possible to flip the tie rod and mount it from the other side. This will require reaming the hole to the correct size and angle using your reamer. Another option is to change the position of your inner pivots. You do that by using rack spacers and picking your steering rack up and down, or if you have a center link, changing your idle arm and pitman arm locations. Pro dive, anti-dive, pro squat, anti-squat, what do these terms really mean? Your suspension linkages have to transmit all of the wheel and hub forces to the body of the car. Just like when we're making a turn, the position of the control arm for a strut car will determine how these forces are applied to the body and whether you have only longitudinal components or some vertical component pushing up. If you have anti-dive during braking events, some portion of the longitudinal force will actually push the body of the car up, resisting the dive. In the back of the car, if you have anti-squat, some longitudinal force will actually push the body up and resist the squat during acceleration events. You can change your pro dive or pro squat by adjusting either the front or back pivot on your control arms. You can do this with shims. You can actually cut and move the mounts, or if you happen to have an inner ball joint like some BMWs do, you use a taller ball joint. Another term you've probably heard is trail and scrub. So scrub is the distance between the steering axis, which in a strut car goes from the upper strut mount through the lower ball joint all the way to the ground. That axis to the center of the rim is your scrub. Larger scrub will lead to greater torque steer in front wheel drive cars. It will also influence your steering effort during turns. And on cars that have significant scrub, you can oftentimes feel changes in steering effort as you hit the brakes. Usually this is the wheel pulling when you hit the brakes. Trail. Trail is very similar to scrub, just in a different axis. Your trail is the distance between where the steering axis intersects the ground versus the center line of the wheel. Your steering axis, just like in the scrub example, is defined in the strut car by the line between the upper strut mount and the lower ball joint. In double wishbone suspension, that's defined as the line between the two ball joints. On most cars, increasing the caster angle will move the intersection of the steering axis forward. That will increase your trail, which will make the steering wheel harder to turn in slow speed turns and will slightly increase your steering effort during high speed turns. It can also change your steering self-alignment, or how much force actually straightens the wheel out when you let go of it exiting a turn. So how do you change your scrub or your trail? Well, if your scrub is excessive, you may want to re-examine your wheel and tire package and try to buy a wheel that has the correct back spacing to get the center line of the wheel closer to where it was from the factory. Changing trail is a little more difficult. That will probably require a knuckle change and a control arm change, both of which are going to be expensive and require a lot of points. The easiest thing to do is to revert back to lower caster if you're having significant steering effort and you cannot turn the wheel, or look at adding power steering to your vehicle. Well, I hope this helped explain some basics in suspension geometry. Make sure you hit the like button, subscribe, and thanks for watching.